Hey everyone, welcome to our today lecture. Today we are going to discuss that how to check the stationarity of the variable. So first of all, we will bring our Excel data into EViews. So already we have done this practice that how can we bring our data into EViews file. So now let's that practice once again. So first of all, we have to click on here, create a new work file, and after clicking on them, we have to write the start and end date of the data. As my data start date is 1980 and my data end date is 2020, so I have to mention the start and end date for my data. In frequency tab, we have to select that in which form we have data. I have data in annual form, so I am going to select annual from this section, and this tab shows that your data is undated. No, my data is dated, so that's why I have mentioned the start and end date here. And this is showing that data is dated. Yes, my data is dated and on regular frequency. And this last option is mean that your data is balanced panel. No, my data is time series, my data is not panel, so we are not going to click on this. We are going with dated or regular frequency. So after giving these options, we have to click on OK. So after this we have to bring our data into a views file. So now what I am going to do, I am going on my Excel file, and from my Excel file I will select all the data and then I will bring that data into a views file. So I am going to select all the data, and my data ranges from 1980 to 2020, and then I will go to quick and I will go quick on empty group, and then I will paste my all data here. Now as you can see that I have my all data in here EViews file. So how can we check the stationarity of the data? You can check it by clicking on the variable name, as ed is my one of the variable. I have double click on it and this box will appear on your screen. Then you have to go to view, then you have go to unit root test. So you don't have to change any options which are set by default. So as you can see that augmented Dickey-Fuller test is used for the checking of unit test. There are also some other tests by augmented Dickey-Fuller test is widely used as, so I am going with this augmented Dickey-Fuller test. So here is the maximum lag. You can change the maximum lag selection by yourself, but now I am going to going with the automatic selection. And here is the you are going to take first difference level or second difference, and these options are showing the intercept, not intercept, and trend and intercept. So by clicking on the default option I will click on OK, and here is the results. So what are the null and alternative hypotheses? H naught or the null hypothesis. H naught or null hypothesis state that data is not stationary, and H1 state that, or alternative hypothesis state that data is stationary. So what is the guideline? How can we conclude the results that our data is stationary or not? We have to check the p-value of the augmented Digifuller test. If its value is less than 0.05, then we will reject H naught. Okay, if I am going to write here, if the p-value of ADF, augmented Digifuller test, is less than 0.05, then we will reject H naught or the null hypothesis. Okay, so as you can see that our results shows that our probability value of the augmented Digifuller test is the greater than 0.05. So we have to accept the null hypothesis. Okay, which means that data is not stationary. Okay, so and there is one another method that you can check either your data is stationary or not stationary. You can check it by looking at these t statistic value. This t statistic value must be larger than any of these values. We have to ignore this minus sign. Okay, this is the second method for checking of the stationarity. If this t statistic value is greater than any of these values, then it means that the data is stationary and we have to reject the null hypothesis, which means that we have to accept the alternative hypothesis which states that data is stationary at level. Okay, there are two options. The first option is that we have to check the probability value. If the probability value is less than 0.05, then we will reject the H naught. And if the probability value is greater than 0.05, we will accept H naught. As our result shows that our probability value is greater than 0.05, so we have to accept the H naught, which means the data is not stationary. And the other method for checking the stationary is that we have to look at the t statistic of the augmented Digifuller test and we have to compare this t statistic value with these critical values. And we have to ignore this negative sign. So our t statistic value must be larger than any of these values for the existence of stationary. So if our data is not stationary, what we have to do? We can do that. We can check it on trend and intercept, or none, or only intercept, as in our case we have check it on intercept. Or you can take first difference or second difference. Now we will check it on first difference. Again, I will go to the view option and I will click on the unit root test, and from these options now I am going to click on first difference. So now as you can see that now our probability value is less than 0.05, which means that I have to reject the null hypothesis. Okay, and when we are rejecting the null hypothesis, it means that we have to accept the alternative hypothesis. And when we accept the alternative hypothesis, it means that our data is stationary now. Okay, and the second option is from the t statistic value, and as per guidance our this statistic value must be greater than any of these three critical values, and we have to ignore this negative sign. As you can see that 3.95 is greater than 1% critical value and is also greater than critical value of 5% and is also greater than the critical value of 10%. So it means that now our this data of this particular variable is stationary at first difference. Okay, so this is the method that how can you check the stationary of the any data.